Welcome to the first lecture of Module 1. So basically how we're going to handle this lecture is we're going to think about the why. And this will kind of break down in a more understandable way to kind of understand what we're going to be talking about in the first chapter for statistics, give you a very basic overview of something in a way that's easy to understand. The second lecture will then be more how we talk about it. You'll have more definitions. It'll be more of a kind of rigorous look at the introductory to statistics. So in this course, I'm trying to pair a reader-friendly textbook with a more technical textbook. So that way you can get really accurate, good precision understanding statistics, while at the same time having something that you can understand that walks you through in a way that's written for a normal human being. So I think that's important. So the basic story here in the wheel and text is he starts with a story to kind of highlight why he wrote this book. So he hated calculus. Basically, when he was taking calculus classes, no one explained the point. So you're kind of doing all this math, but to what end? But he ended up loving probability and physics. These are courses that are really connected to real life and where the problems that you're doing have real world implications and often use like examples or units of things that you would see in real life. So what I'm trying to do in this course is make the intuition clear first, and then once we cover that, then add the math from the other textbook. So one of the examples he gives in the opening introduction sort of series of vignettes is he walked through the distance to the wall example, something he came up with in class to try to describe what was going on. So you have the factorial here where one is converging to two, and they were trying to think about like how to handle that. So he said, imagine each step you're moving half of the distance to the wall. So you start at 2 feet, you move to 1 foot, then half a foot, quarter foot, all the way. You keep getting closer and closer, but you never quite touch it. That's how he came to understand the asymptote. Um, so that's kind of what we want to handle with this chapter and with this textbook as we go throughout the course. Now, statistics can seem a little scary, it can be a little daunting, but there are statistics that we use in our real life already, something that before we even get to the classroom, that we're comfortable with. So think about ones that you already use in your casual life. So something like maybe batting average if you're a baseball fan, your GPA if you're worried about your coursework, or maybe something at work like a KPI number, something. These are numbers you use to track things over time, maybe your individual performance or other performances, and to compare between observations. Maybe you're comparing two different baseball players, or you're tracking your favorite quarterback's passer rating over time. So one, two, and three here, these examples you see on the slide, these are things that you may be comfortable working with. Um, but then we get to the fourth, the Gini index. This is something we use in economics to describe income inequality within a society. So we calculate it using calculus, the integration between a 45-degree line, a specific curve that represents the income in a society. This is basic Calc 2 stuff. Um, so often sounds complicated. But the Gini index isn't really different from a passer rating. And if you look at the old passer rating that went up to like 153.8 in the NFL, that was really complicated to calculate, a really weird looking formula. Um, so Gini index is difficult to calculate, but we use it the same way you would use a passer rating, the same way you would use GPA. It might feel harder because of the label of economics, but in practice, the way we would use it to compare isn't any different. So we can use the Gini index to compare income inequality in a single society over time, or we could use a snapshot of multiple societies and compare them to each other. Now, we may have differences in opinions over what level of income inequality is good or bad. Different preferences are okay, just like we see this with different sports statistics. But what we're doing here is comparing some sort of tangible number. So if you're comfortable with a passer rating or a GPA, you're already halfway to being comfortable with the Gini index. So I want to show you a headline, and imagine you're scrolling through the news and you see this. People who take short breaks at work are far more likely to die of cancer. Now, you might have a flash warning going off in your mind that this is just clickbait. Um, But let's look at the study behind it. So researchers looked at 36,000 office workers. So it's a pretty large sample. A serious data set that we're working with. It's not like they just polled 8 people and they found something like that. And they found that these workers who reported leaving their office for regular 10-minute breaks during the day were 41% more likely to develop cancer over the next 5 years than the workers that didn't leave their office at all. 41% with a sample of 36,000 people. If I told you that, would you believe it? Or would it feel something like um, that you'd be worth acting on? So maybe a new company policy or public health campaign, actually doing something to not let people leave their office because apparently leaving their office is so deadly. So what would you do with this information if you were a manager, if you were a policymaker? So here's the problem. Think about what people are actually doing on that 10-minute break outside the office. A lot of them are standing by the entrance smoking cigarettes because you're not allowed to smoke inside of businesses anymore. So it's not the break that's causing cancer. It's the cigarette that they're smoking during the break most of the time. I'm sure not 100% of the breaks in this study were smoke breaks. It's not the break itself, it's what they're doing. Now, this is a fictional example that Whelan made up on purpose because it's a little absurd, but it highlights the difficulty we see with real statistical misreadings. Um, and we can end up with some ridiculous results when we look at statistics the wrong way. Now, the lesson isn't for you to just have a blanket, don't trust statistics. It's when you see a striking number, your first question should be, what else is different between these two groups? This is the seed of something we're going to spend a lot of this semester on. We call it a confounding variable, where there's this third variable that's impacting the two that you're looking at. So I don't want to dig too much into the passer rating, especially the textbook uses Jay Cutler and Aaron Rodgers. I think Rodgers is still in the league. I don't know if he actually retired yet. But yeah, so think about GPA and the honors weighting. This might have been something you dealt with way, way back in high school. Um, So it's easy to compare when all the courses are the same, but once you start weighting the courses differently, you can end up with something different. In an extreme case where an A in a class like a gym class can pull a strong GPA down because you get those extra points for the honors. So it makes the comparisons really difficult. The same thing with like the passer ratings. So yeah, let's move on to the Gini index, something a little bit more concrete. So we see several countries here. So we see Sweden with the most. Oh, let me move my thing a little bit so you can read more. Um, so the 0, the lowest possible number, is perfect equality in a society. Everyone earns the exact same amount. And 1 is perfect inequality. So one household owns everything and no one else owns anything. So we see might not be surprising based on the news or what we hear about the world, but Sweden has a perception and has very low income inequality. Canada has slightly higher income inequality, China a little bit higher, and then the US. And then we have some examples of unequal societies like Brazil or South Africa. So from 1997 to 2007, the US Gini index rose from 0.41 to 0.45. So back then we would have been beating China if they stayed the same. Now, is this trend over time of recent years is the US having more income inequality? Is this automatically bad? That's not something we can exactly answer right away. We might look at other contexts or other variables. So what happened to median income over that period, not just the distribution of income? Are the people earning the high incomes and low incomes changing over time? So is there economic mobility between lower income to higher income? Those are sorts of things we want to answer before we just said that that an increase in the Gini index is bad. But this is one of those things that you can look at, and in general, you could say, well, a country like South Africa with really high income inequality is going to be worse than a country like Sweden with really low income inequality. Statistics can tell part of the story, especially when you just pull one number. It can tell you something, but it might not tell you everything. Okay, so eventually in this course, we're going to talk about inference, where we take a small sample of data and we use that to try to understand and make predictions about the large population. It is really difficult to survey every single person in the entire US. We do a census every 10 years because of the time and the cost and the effort it takes to get every single person. So, um, if we're doing a poll about who supports a candidate, we're typically not going to ask every single voter. That's crazy. We just look at we take a small number of voters. We hope that that sample is representative, and we use that to try to understand the population, estimate what the whole population is, what their characteristics are, whether they support the candidate, whatever the question is. So let's say we wanted to count the number of homeless in the US. That could be really, really difficult. Um, but a handful of census tracts, so small areas in the US, lets researchers estimate a citywide population. So you can look at just go to specific areas in town, count how many homeless people are there, and use that to estimate what is there in the whole city. Much cheaper, much easier, much quicker than trying to count everyone. So for political polls, Gallup is one of the household names that you hear for polls. They have a really well-designed sample trying to get all these different characteristics in there, different households, but they use about 1,000 households. And because it's such a good sample as representative of the entire US, they use it to understand what's going on in the United States as a whole. So you can have relatively small samples, not a large group of people, but when they're well done, they can be very representative of a large population. Okay, I kind of like this reunion example, so it's worth slowing down and taking a look at one of the issues with that we find in statistics often, with selection bias. This is something that's going to show up through this course again and again. So since you can't ethically run an experiment on the health risks of smoking, you can't randomly select people from a group and say, you're going to smoke a lot for the next 20 years. You are not going to smoke a lot. We have to look at observational data. So you look at the world around you and you try to break it up so that it's as if you were running an experiment on those two groups. But let's say you try to look at around your 20-year high school reunion. In economics, we're forced to rely on observational data all the time instead of experiments. If smokers appear less healthy, you might think, boom, there's the evidence. Okay. But we need to stop and think about this. When you rely, oh, sorry. When you rely on observational data, you open yourself up to a host of other issues. So for one example, smokers may share other unhealthy habits. So maybe they drink alcohol more, maybe they exercise less, maybe they eat other unhealthy foods. And the sickest smokers, the ones that are suffering the most, are least likely to show up to a high school reunion. Or perhaps they're the least likely to show up. So these things create what we call selection bias, where certain people are less likely to do other things, which really complicates our analysis. So this is how the chapter sets up regression analysis, which we're going to talk about later. What we try to do with regression analysis is isolate a relationship while holding other factors constant. I don't want to walk you through equations yet, but the basic idea is you'll include other characteristics, so maybe things like diet, exercise, their weight, so that you have more of an apples to apples comparison, kind of getting rid of that or reducing that that selection bias that we're facing here. Okay, so there are limits to statistics. I have to move my thing again because I put Mark Twain there in the upper corner. That came up with the quote, "There are lies, damn lies in statistics." So statistics on their own can rarely yield the truth. Usually something that's circumstantial, built on imperfect data. This is a step in the right direction. Just because you can attach a number to something doesn't mean that we have found the true perfect effect, and that is it, case closed. So this runs through just a few of the potential issues. And it starts with something basic. We may actually disagree about the question being asked. So if you look at best baseball player or best basketball player ever, who is the GOAT? ESPN loves to fight about that. Um, no one statistic will settle it. So people, the talking heads will argue between LeBron and Kobe and Kareem and whoever else you want to put in that list. I'd probably put Shaquille O'Neal, but that's definitely personal bias. Uh, Next is we can't always run the ideal experiment. Um, I would strengthen that and say we can very rarely run an experiment, let alone an ideal experiment. So there are some studies, maybe something like terrorism, long-term health outcomes, or even a lot of economic policies. We simply can't be done in a controlled experiment. Some of them are we just can't ethically do because we know there's going to be a negative effect on some people. Some of it might be that you really can't get a clean control and treatment group. Next, smart, honest people can disagree. So not even people that are liars or fools are going to disagree, but honest, smart people can disagree. And there are a lot of debates that go in different professions. Economics, we debate about things all the time. Really smart, honest people coming to different conclusions from the same sort of data. And given the fact that we often have imperfect data, so we don't have the whole population, we just have a sample out of the population. When we analyze that data, reasonable people can reach different conclusions. But worse yet, not everyone is honest. So some people take these tools that can reveal the truth, can provide some evidence towards the truth, but they can twist them. They can use it to dress up nonsense. Think of how to lie with statistics. Um, we can use them to conceal as much as we can use it to reveal the real world. And we could spend an entire course and an entire module talking about how to lie with statistics, the difficulty of dealing with other people that are lying with statistics. So let's come back to the question this whole chapter is built around. And really the question that this course is built around. So what's the point? Why should we study statistics? How can statistics help us? And what are some of the tools that statistics gives us? So Whelan gives us 7 different answers. And if you look back at this talk for the last 10, 20 minutes, we've touched on them. So first is summarize huge quantities of data. So that's things like the passer rating or GPA. There's 90 plays in a football game. It gets boiled down to one number for the quarterback. You take a ton of different courses, ton of different assignments within those courses. You learn quite a bit, hopefully, and that gets boiled down into one number, the GPA. Statistics can help you make better decisions. So that's the Gini index conversation. You can't manage what you can't measure, and you can't measure fairly without some agreed upon yardstick. So if you're concerned about differences in income in a country, the Gini index is a tool. It's a figure that can give you a good point of comparison. Statistics can help you answer important social questions. So again, think of income inequality. This can be very, very important. The homelessness sampling. That's using polling to understand important social questions. Next, it helps you recognize patterns. From selling diapers to catching criminals, you can have the same logic for whether it's a business trying to, to maximize their sales and ultimately their profit, or whether it's trying the police to try to maintain safety. So wildly different applications using the same logic. It can help you catch cheaters and prosecute crime. Really the same idea, but more literally applying it. It'll help you evaluate policies, programs, prescription drugs, company procedures. So the stent study that's going to be coming in the next lecture is a great example of drugs and health outcomes. And later on in the course, when we go through regression analysis, we'll be evaluating different policies, programs, prescription drugs, procedures, these sorts of things. And finally, statistics gives us the tools to spot the scoundrels who misuse these tools. So the short breaks in cancer story we walked through, if someone was trying to be dishonest, they could use those statistics to make you think just simply getting up from your desk is bad. Maybe that wouldn't trick you because that's an extreme example, but there are many, many other situations where we can trick someone using numbers. So if there's one thing that you take away out of this lecture, more than any single example is that statistics isn't a math requirement that you need to get out of the way to get your degree here. So what I'm hoping to develop here in this course, especially because this is a more applied business program, is you should be skeptical of striking numbers, trying to ask what's being left out or who benefits from a particular framing, and to think through how we can use these numbers or statistics and try to make comparisons between groups, between potential outcomes, or to track performance of one individual or one line of your business over time.